the last video we have discussed about the data independence and what are the types involved in the data independence, like logical data independence, physical data independence. Now today we are going to focus on structure of DBMS, or we call it as architecture of DBMS. In this video we are if you see this diagram, the users are at the top level, naive users like tellers, agents, web users, application programmers, sophisticated users, database administrators. Obviously each users will be preferring some set of tools like query tools, administrative tools for their activities, and here is the tool level. This we call it as tool level. And if you see the architecture diagram, we have two important components. One is the query processor and another one is the storage manager part. We'll come to this later. And also if you see the databases are actually stored in the disk. So in this example we are assuming that a database is actually stored in a disk, and that's why this storage is referred as disk storage. So in the database architecture, we are going to exclusively focus on the individual components that constitute this database architecture. I mean the components in the query processor and the components in the storage manager as well as disk storage. In this video, we are going to focus only on storage manager, and the remaining we'll see in the next part. Okay, now we'll focus on storage manager. I mean we are going to focus on buffer manager, file manager, authorization, integrity and manager, transaction manager. So let's see one by one in detail. So first going to discuss about the storage manager. Before going to discuss about storage manager one by one, first we need to understand why do we need this storage manager and what role it plays in the database architecture system. Basically, this storage manager provides the interaction between low-level data stored and the application programs, right? If you see the architecture diagram, this storage manager provides the interaction between the application programs, right? You can see here it is provides the interaction between the application programs, that is from top level, and the data stored at low level, right? So here is actual data is stored, and to be precise, here is actual data stored that is stored in the database. Actually this storage manager handles all the queries that are submitted to the system. What do we mean by this? If you see the architecture diagram, the query processor process the queries, and this will give the request to the next level, which is the storage manager. That is why I said this is also having an interaction that is received from the query processor to the disk storage, right? And also this storage manager is having the interaction with the file manager, right? Also having the interaction with the file manager. You may be asking me a question like we have already compared file system versus database system, and we understood that databases are more advantageous over file system in effective storing and retrieval of data. Even though we are saying that it is a database system, internally it is made up of files only, but it's not going to work as a regular file system. Rather it is going to work differently. Why? Because we need to effectively store and retrieve data in database management system. At the same time, the various drawbacks that we have seen with the file systems needs a solution. Here though we are using internally all files, but this is not going to work as per the file system concept. It's going to work as per the database concept, right? It's going to work as per the database system concept. And also we know that only low level data are stored, and this low level data is actually the raw data that are stored on the disk using file system provided by the operating system, that is OS. Now obviously whatever the interaction we make, see we may do some insertion or deletion or upgradation or updation. Whatever it is coming from the front end or from the high level, those data have to be stored in the database, and that is to be precise. It has to be stored on the disk only, because this database is on the disk only, right? So all the raw data are stored on the disk, and what format is going to use? This is going to use the same file system format that is provided by host operating system. So we are clear that if data are stored on the disk, it uses the file system provided by the operating system, and these raw data are provided from the users or the application layers from the topmost layers. And what about the DML commands? What do I mean by DML commands? Right, these DML statements are the statements that deals with the insertion of data or deletion of data or updation of data, or sometimes a selection of data from databases also. We know databases are going to store data, and data related operations are built by these DML statements. For example, select, insert, delete, update. When such commands are received, this storage manager only translates the various DML statements in low level file system commands. Why? Because the internal organization needs to be supported by the operating system, and this operating system obviously will be using some file system, and whatever the data manipulation language commands that we give, these things have to be translated into the low level file system commands. In simple terms, we can say that this storage manager is responsible for storing, retrieving and updating the data. Now we'll see various managers that are there in storage manager as per the architecture diagram. We are sure that we have 4 components in the storage manager part, that is a buffer manager, file manager, authorization integrity manager and the transaction manager. Right, let's go the architecture diagram, and first we'll focus on the storage manager component, the buffer manager. First one is buffer manager, and this buffer manager is actually responsible for fetching the data from the disk storage into the main memory, and also this buffer manager decides what data to cache in the main memory. I hope you are already aware of cache memory in computer systems. This memory is mainly used for what? For faster access, right? So buffer manager takes care of this. At the same time, this buffer manager is very crucial in terms of another important operations like handling the size of the data. Right, so this is about the buffer manager. When coming to the second one, the file manager, we know already this is a mainly for allocating the space on the disk storage and also the data structures. We have a lot of data structures followed in the disk storage, and this file manager is used to represent the it is used to represent into the stored on the disk, and coming finally we can say that this file manager is mainly for allocating the space on the disk storage and also on the data structures also. So this is about file manager. When coming to the next one, that is authorization and integrity manager, this component or this manager is used to test for the satisfaction of all integrity constraints that we enforce on the database. Authorization itself, we can say that who have access to take the data. Like authorizations, we have so many authorizations are there, biometric and all these will come into authorization, integrity and manager. So when coming to the next one, coming to the last manager, that is transaction manager, and this transaction manager is a very important part because this ensures that database remains consistent despite system failures or any hardware or software failures. At the same time, this transaction manager ensures that the concurrent operations carried out on this database are actually not conflicting with each other. I mean, concurrent operations are permitted. Multiple users can access the shared data item at the same time without conflicting each other. So this is ensured by the transaction manager. So this is all about storage manager, which is buffer manager, file manager, authorization, integrity manager and transaction manager. In the next part, we'll going to see about disk storage and all the remaining parts. Hope you understand this concept. If you like this concept, if you like this video, please like, share and comment. Thank you.